Okay, today we're going to solve nonlinear systems. Okay, so here's an example. You have two equations, y equals x squared and y equals x plus 2. Okay, so in grade 10 you would have done solving two linear equations. So in grade 10, if this was a line and this was a line, then solving them meant where did they intersect. Okay, we're doing the same thing, but this time it's not two linear equations. Okay, so we're going to do this in three methods. I'm going to show you all three methods for this one particular example. So we're obviously going to get the same. Okay, method 1, elimination. Okay, so we're going to put them on top of each other. So what can we eliminate? We can eliminate the y's. So I'm going to rewrite this a little bit better. I'm going to say y equals 1x squared plus 0x plus 0, so that I have an x squared, an x, and a number. Okay, I didn't change anything, I just wrote it better. So y equals, now in this one I don't have any x squareds, so I'm going to make sure I just write that so I know I have a 1x and a 2. Okay, so now we decided that we could eliminate the y's, so I can do that by subtracting. So y subtract y is 0, x squared subtract no x squareds is an x squared. 0 subtract 1 is negative 1x, and 0 subtract 2 is negative 2. Okay, so now I can see I have a quadratic, which is a simple trinomial factoring. Do you see that? So 0 equals 2 brackets. Hello? No, it's his room, but he's in the lab for class. Okay. Okay. Okay, so back to factoring simple trinomials. So we should have x, and then we need a 2 and a 1. This would need to be a negative, and this would need to be a positive. So my solutions would be x to be a positive 2, or x to be a negative 1. Okay, we're not done though, because I need to also know my y value. So what you're going to do is place this x value in to either equation. So when x equals 2, y would be 2 squared, or 4. Okay, what if x was negative 1? So if x was negative 1, then y equals negative 1 squared, which is positive 1. And these are my two solutions. Okay, so it doesn't matter, you could have plugged it into number 2. You could have gone y equals 2 plus 2, which is 4, or y equals negative 1 plus 2, which is positive 1. Okay, two solutions. Now, let's try this by substitution. Okay. I'm going to rewrite these so we can see them on the page. So you can substitute anything that's equivalent to one thing. So if y equals x squared and y is also equal to this, can you see that I can replace this with that y because I know that this is equal to a y. So I can replace it, substitute it in there. Okay, so into equation 1, the y is getting replaced. So do you see how right here, that's just a replacement of the y. Okay, so from at this point, I see x squareds, x's, and numbers. So that's all three pieces of a simple trinomial quadratic. So to solve those, I need to have equals on 0 on one side. I always suggest where you have the squared term to keep it positive because it's easier to factor. So instead of bringing it out to that side and making it negative, I'm going to actually take everything to that side. So subtract x, subtract 2, and you get 0. If you don't, on this side, you're going to have that subtract x and subtract 2. Now we have factor, same as before, same solutions. Okay, and then we obviously plug it in when x is 2, and then you plug it in, 2 plus 2, so y is 4. If x is -1, -1 plus 2 is 1. Okay, so same thing, different method. And the last method is graphing. Okay, so y equals x squared. That's your basic parabola. Starts at the origin, 1 over 1 up. 2 over 4 up. 3 over is 9 up. Okay, remembering that 1, 1, 2, 4, 3, 9 pattern. Okay, equation 2. Y equals x plus 2. That's a linear equation. So I'm going to start at 2, and my slope is 1 over 1. So I'm going to go up 1, right 1, up 1, right 1. And I'm going to draw a line. And then my solution would be, where do they intersect? They intersect at the point 2, 4, and they intersect at the point -1, 1. Okay, so obviously all three of those came to the same solution, different method. Okay, let's look at example 2. Okay, so if I just give you an example, I don't say which method to pick, what would you do? So looking at this, I can see that elimination would be the easiest, and I can see that if I add the two lines together, that those would disappear. So I'm going to add, and I'm going to go 3x squared, those cancel, 27. I'm going to divide by 3, x squared equals 9. So therefore x equals, now here's the trick, I could have a 3 squared to get me 9, or a -3 squared to get me 9. So I have two solutions for x. Okay, now let's figure out what y is going to be. So I'm going to plug in. Let's pick equation 1. So x squared, I'm going to replace that with 9, minus y squared equals 5. So take away 9, I get -y squared equals -4. Divide by -1, so y squared equals 4. Therefore my y is equal to 2 or -2. Okay, so if I write these as an answer, I'm going to write it as an ordered pair like this, saying that x could have been ±3 and y ±4. So you actually could have 4 combinations. You could have a 3, 2, a 3, -2, a -3, 2, a -3, -2. Okay, next example. Equation 1, y plus 71 equals 5x squared plus 1, and y plus 4 equals x squared minus 2. Okay, so I think I'm going to do substitution on this one. So let's get y alone somewhere. It doesn't matter. Let's pick number 2. I need to subtract 4. So y equals x squared minus 6. Okay, now we're going to take this, which is equivalent to y, and you're going to substitute that in for the y in the other equation. So equation 1, instead of y, I'm going to write x squared minus 6 plus 71 equals 5x squared plus 1. Okay, so isolate, and then you can replace your y. Okay, so in this, I don't see a full 3-piece quadratic because I just have x squareds. I don't have x's. So therefore, I can just use isolation, get my x squareds together, isolate them. So let's move this to the other one. So we get 4x squared plus 1. And then 71 subtract 6 should be 65. Then I'm going to take this one off. Then I'm going to divide by 4. So 16 equals x squared. Therefore, x is a plus or a minus 4. I need y now, so I'm going to plug in. So looking to plug in, I'm going to go y. I'm just going to write this over here. Y equals x squared minus 6. So y equals x squared. I can replace x squared with a 16. And then I get y equals 10. So you can write this as that, or you could say your two intersection points are 410 or negative 410. Those are your two solutions. So I accept if you want to write it like this, or if you want to write it as two separate solutions, that's okay as well.